In this lesson, we're going to investigate the resistance of a lamp with a practical demonstration. Now, to help us understand this, we're going to revisit Ohm's law. So here is a slide that we've seen before, and here I have a simple setup for Ohm's law. So let me recap what Ohm's law is. Ohm's law is where an ohmic conductor, such as a fixed resistor, obeys Ohm's law. Well, what does that mean? It means that I will have a resistor that has a fixed resistance. In other words, if I investigate with an experiment, I will get a straight line through the origin. Now, how would I do this? Well, in this setup, I have a cell, an ammeter, which has very low resistance because its purpose is to measure current and not affect it. Here I have a fixed resistor with a voltmeter connected in parallel. A voltmeter has a very high resistance, again, so that it doesn't affect the circuit, that it only measures the potential difference between these 2 points. And then I have a variable resistor that can control current. Now, why do I want the variable resistor? Because when we do experiments, we do it more than once. So I would vary this variable resistor several times, get different current and voltage readings, draw a table, plot a graph, and an ohmic resistor will give me a straight line through the origin. Well, what about a lamp? Let's look at the experimental setup. Now here, just like the Ohm's law experiment, instead of one cell, I have two cells, in other words, a battery. I have a multimeter set up as an ammeter. A multimeter is basically a device that you can set to measure current, voltage, or resistance. This one's set to measure current connected in series, and this one's set to measure voltage connected in parallel. Now, normally I would put the voltmeter underneath the bulb. Because the bulb was so bright, it was obscuring the numbers, so I put it above instead of below. And on the right-hand side, I have my variable resistor that controls current. So this is basically pretty much exactly the same as the setup you saw for Ohm's law, except instead of one cell, I have two. And instead of the voltmeter being below, I put it above. And instead of the fixed resistor, I've got a lamp. Now, what I want to demonstrate here is that if I vary the resistance of the variable resistor, you will see that the voltage and current changes. And what we can now do is basically draw a table, and we can keep altering the variable resistor 3 times, 5 times, 10 times, depends how much time you've got in class. And you can notice that the bulb's getting dimmer and dimmer as I make the resistance bigger and bigger. Well, why is that happening? Because basically the current is becoming less and less. As a way of a brief introduction to a variable resistor, this is known as a solenoid. It's basically a big coil of wire. And what happens is the current will flow through this wire until I give it a path to escape, which is this low resistance beam here. So what's happening is current's going round, 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 round till it gets to here, and then I allow it a very quick path to get out. If I bring it all the way back, notice that the bulb is very bright because current doesn't have to flow very far through this coil of wire, comes straight up this beam and out, and therefore the resistance is low. If I make it go all the way to, well, let's say over halfway through, basically the current's going round, 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 round this coil of wire. Remember, resistance is proportional to length, up and out. And then this is what you are seeing, a very low current and a very low voltage across the bulb. Anyway, let's keep it nice and simple. All we're doing here is varying the resistance, which controls the current, which gives us a different voltage and current reading. Do this 5 times, do this 10 times, and what you'll end up getting is a table that you can draw. And from that table, we will plot a graph. Now, what does the graph look like for a bulb? Well, it's not the same as an ohmic resistor. It looks like this. It is a curve. And what this curve is telling us, that basically as voltage gets bigger and bigger and bigger for a bulb, the resistance gets bigger and bigger and bigger. In other words, it's not constant. Well, why is that? Well, a bulb will heat up. And when it heats up, the lattices, the vibrations will be more and more and more. And basically, the charges will find it very difficult to flow. So the resistance goes up. So what we've looked at here is the actual practical demonstration for a lamp, which is very much the same for a fixed resistor. We've taken several readings. We draw a table. And by the way, this table is not based on what I showed you. It's just made up. But you get the idea. And then when you plot the graph, it's not a straight line through the origin. It's curved. It's curving towards the voltage end. In other words, voltage is getting much bigger compared to current. And therefore, since R equals V over I, the resistance increases.